everybody. We got the next talk starting, so we'll get this going. I want to introduce Eric Forner. Eric Forner is with Armexa. He drives the technical direction of Armexa by identifying, developing, and implementing ICS OT security technologies and architectures. He is a licensed professional engineer in the control systems engineering discipline. He specializes in ICS OT cybersecurity with expertise with OT ICS security operations and engineering, industrial network design, and plant floor systems integrations. He has extensive experience working with various technologies and process controls, building automation, and enterprise IT. So everybody give a hand to Eric Forner and he'll get started.
All right, everybody, good morning. How y'all doing? Ready to talk some OT? Let's do it. Let's do it. So what we're going to talk a little bit about today is I've been doing OT for a while now, mostly on the engineering side, but recently I've been on the IT side of the house. So what I wanted to talk about was more of a practical way to turn OT cybersecurity into an engineering discipline, along with all of the sort of the rigor that your civil, your mechanical, your electrical colleagues, sort of the things that they do, sort of integrate that into our own cybersecurity practices. So just very, very quickly about myself, I am the CTO of Armexa. We're just about a 2-year-old company. I have my degree in mechanical engineering, but I've been doing control systems for a while and have my PE in that. I've been doing this for about 14 years now, but really I came from an asset owner. I've been an asset owner for most of my career, working for Air Products. I started my career as a Siemens PCS7 DCS engineer, and then have worked for smaller companies that have since been acquired, like Cymation. And then I also worked at Anadarko for a fair amount of years before they were acquired by Oxy. I was on a team of 2 people. We were the OT infrastructure and security arm, reporting under the IT business units, but we supported about 75 facilities to include the Gulf of Mexico. So I know there's a ton of different goals as an asset owner. There's a lot of different things that you guys have to worry about, but I just wanted to highlight a couple of them that I have seen as an asset owner, have been working in consulting, have been doing these engineering projects for a really long time now. But one of the first ones, and we're going to really deep dive into this today, is follow that same engineering methodology cadence as your engineering colleagues. So I'm sure a lot of you know when you look at greenfield capital projects, there's sort of a defined way, stages of delivering these capital projects, and we can do OT security in a lot of the same ways. Number 2, this is a particular passion of mine, especially as an engineer, but focus less on the paperwork, although it is critically important, but more on taking action. And what I mean by that is I have personally seen a lot, and certainly at the old company that I worked for, is that we kind of get stuck in these trenches of making tons of documentation, a ton of roadmaps, a ton of recommendations, and then nothing gets done. So I'd like to see if we could turn it on its head a little bit, and I know a lot of you guys are already doing this today, but make those assessments and those roadmaps and those risk registers in service of actually getting the work done, not really focusing so much on those assessments and then just sort of leaving the implementation to do whatever, because really where the rubber meets the road, in my opinion, is the implementation. And the third one is there's a lot of things we can do, a ton of things we can do, and they can be really cheap and they can be really expensive, they can be disruptive, or they can be very light touch. But there's some things, and we'll talk about today, if you're just starting this, there's some things you can do just to immediately reduce that risk to industrial operations. And it doesn't necessarily have to be a giant segmentation effort where you have to re-IP everything and call in all of your skid vendors and get things recertified. And the fourth one, which I personally think is probably the most important, is make it easier to do the right thing. Because at the end of the day, people need to get their job done. So, everybody knows you kind of have this sliding scale of convenience and security. On the OT side, personally, is I sort of want to slide it a little bit to the left just to make sure that we put sensible security controls in place and we make it easy enough for people, SIs, or whoever's going to come in to do their job. They go and they just do it according to the way that you guys have defined, other than just plugging into the network because they have a job to do. So let's talk a little bit about cybersecurity as an engineering discipline. And I'm sorry, this might be a little bit hard to see here. But here's kind of an overall workflow. And this doesn't have to be how your organization does it. This is just sort of a generic way that I have seen when I've been executing these projects to have them integrate well into engineering functions. So let's just start at the left here. We have the project initiation. We do a very quick project risk assessment. Does not have to be hard. Mostly what this is data gathering around what are we doing? Is this a brownfield remediation? Is this a greenfield project? What kind of are we doing? And really what that leads into is, does it have cyberscope? And that kind of can be confusing about what that means, but it usually comes into two additional questions. Can it affect an industrial process? Yes or no? Does it have an IP address? Yes or no? And if the answer is yes to both of those, yes, it has cyberscope. If it doesn't, we probably don't need to worry about it. So let's say that we do have cyberscope, because we're probably getting engaged if we do. So we'll move over to, are we using a vendor? This should be pretty self-explanatory, but I have seen, and I'm sure you guys have seen, that almost always in these projects, we are using some sort of vendor, whether they're a skid vendor, whether an SI, whether they're a DCS OEM. A lot of these guys are involved in this, and that's not just cybersecurity. We're talking about any vendor that's going to be configuring or being responsible for a device that has an IP address. So what do we do with those guys? Well, what we can do is we can sort of front load them, hopefully in the RFP process, of what do we expect? What do we expect from you? Do we expect to understand what your data flows are? Do we expect to have managed switches? Like those sort of things, getting that caught early helps a ton, because everybody knows that brownfield remediations cost 5 times as much as doing it on the front end. So the next two are, this is sort of a methodology that we came up with because not every project is the same. Some of them are super big and very expensive and very involved, and some of them are just very small projects that might just be to enhance the OT cybersecurity, and we don't really want to put that same rigor on every single one of those initiatives. So really what this workflow is it a large engineering project, which really means, does it have a feed? And by that I mean does it have an engineering feed? Because if it does, what we can do as OT cybersecurity practitioners is inject ourselves into that process. It doesn't have to be crazy. This is just getting data gathering, stuff like that. What are the subnets that we're going to need? What are the IP ranges? What's the bill of materials that we might need to put together before we move on to detail design? So you can kind of see here, you kind of work through this same engineering cadence, right? So you start with a feed, move to detail design, same as the automation and electrical folks, then do a factory acceptance test. Anyone who's worked on plant floor and has worked in control systems knows FATs are critically important. So I would contend that as they are doing their FATs, that we do checkouts as well, because we are probably installing endpoint security tools on there. We're probably managing or putting configurations on their switches. That can affect, if we do that after it's in the SAT phase or during commissioning, it can just generate tons of punch list items that were never addressed in the FAT. So if we can get in there with those engineering folks, the control systems folks, during their FAT and punch list generation, we're just in a better spot. And of course, at the end, an SAT. So you can kind of see that cadence for these large engineering projects, but we can kind of scale it down, right? So let's say we don't have a huge greenfield project. Well, what we can do is we can simplify it, but we have to ask ourselves one critical question, does it have the potential to disrupt the industrial process? Can it do it? Can it do anything to be able to cause a loss of control, loss of availability, loss of view? Can it do that, this technology that we're introducing? And if the answer is yes, by golly, we should do an FAT. If not, if it's just something that's providing for visibility, asset management might be a good example of this. It's just a span port, as long as it's configured correctly. That can't affect the industrial process. So in that case, we can go through the detailed design and go straight to SAT. One of the things here that you can kind of see at the end is this gap assessment. And most of you know what a gap assessment is, I'm sure. But the reason why it's critically important to do one of these after any one of these projects is that it sets a baseline of where the facility is at that moment. Because we always know that at any large greenfield project or any capital project, we are not going to close every gap. We're going to try, we're not going to satisfy every control. We are going to try, we may get there most of the way, but there's always going to be something. And what this does is it helps us when we go back to do a remediation later on. We kind of already know where we are. It sort of drives that roadmap, and we can see the progress of, oh, we've done this large greenfield project, we're at 60%. We go back and we implement this technology, we're at 80%. So you don't have to do a new gap assessment every time. You're just updating it, and you're showing progress through this engineering workflow. So this gets a little bit more detailed, and again, I apologize for the text is kind of small, but we'll kind of run through it pretty quickly, is as you're going through each one of these, you should have a defined set of deliverables that either you as the asset owner complete, or one that you define during your RFP process that your vendors do. And here's a couple of them, and you guys probably do a lot of these already, but something like a logical system diagram. Hopefully we're going to have a couple of VLANs. We should know where those VLANs are. A physical network diagram, so that would be everything from you have a switch, what is plugged into what port on what switch, and how is everything physically laid out. Extraordinarily important when you're going into run and maintain. A system integration specification. So let's say you have a ton of skid packages. You have your compressor skid, you might have HVAC, you might have whatever. But how do those things integrate into the larger DCS if you have one of those, right? Is it Modbus, and is it going through a third-party gateway? Whatever. And then a network register. So that's anything that has an IP address. What is it? What operating system is it running? What firmware is it running? Simple stuff, right? But these are just defined deliverables that you guys can give to your vendors, your SIs, if you decide not to do it yourself, and say, I need these things because these help me get to, gives me the information I need as an OT cybersecurity engineer to do my job. We have a data flow register, deployment procedures, stuff like that. So anyway, so here's a deliverable package, right? And that deliverable package needs to be reviewed by someone. Typically, it's going to be one of you guys as an asset owner. And so, well, who is that person? Is that person IT? Are they OT? I would contend it doesn't matter. What I kind of like to do, and I didn't come up with this term, but this concept of technical authorities, where essentially you have three hierarchies of technical authorities. You have a TA3, who is kind of the person doing the work, a TA2 who's kind of over the project, and a TA1 who is over a program. And just define who those people are. They can sit wherever. But what you can do in this engineering cadence is say, okay, I want somebody to review the detailed design package. That needs to be a TA2. That person, whoever they are, is specified in the policy, so it makes it really easy to sort of understand, who's who in the zoo. So after that, we move to execute, where we end up doing our site acceptance test. And you can kind of see here is that SAT is reviewed by someone, typically a TA2. It is approved by someone, typically a TA1, and then you move into your gap assessment. So you can kind of see, hopefully, this sort of defined process. And some of you who work in larger oil and gas companies might recognize define, develop, execute, and close. Just how engineering executes projects. which can be very different from how IT does it. And I would recommend, even if you sit in IT, which I did, you follow that cadence of the engineers instead of perhaps your PMO. That's how I've seen it work better. So from here, we won't go into each one of these, but essentially we're just sort of building, right? We're just, as these get more complex, we add a little bit more stuff. So for here, for instance, all we're asking for is if it has the potential to disrupt the industrial process, that we add an FAT. That's it. We just want to make sure when we're introducing this technology that it won't disrupt anything when we get there. It's the same overall timeline, the same overall process, but we're just adding a little bit of extra controls to make sure that we don't, frankly, screw anything up when we get to the facility. And the large one, of course, what we're doing here is just adding in that front-end engineering design piece. Again, same cadence, same deliverables. We're just adding in that additional amount of rigor so we have an idea of what we're doing when we go and we go into our detailed design. Cool, so that's, in my mind, how you actually do sort of this detailed engineering cadence that you guys can work with your engineering colleagues to do capital projects. And that could be anything from building an offshore facility to implementing asset management, to implementing a remote access solution. That same methodology can be used for any one of those. But let's say that you kind of got that down, or let's say you don't want to use it at all. There are some design and remediation principles that at least I have seen in my years of doing this thing that I've seen have helped me, and maybe they'll help you guys. One is, if you're just starting, I, as a network engineer, really believe in segmentation. I think it's critically important. But I also know is that it can be A, expensive, and B, super disruptive, especially if you're in a regulated industry like pharma, where you have to submit the IP addresses as part of regulatory documentation. Changing those IPs is non-trivial. But there's certain things that we can do, and this is not rocket science, guys, but you can do some very short-term immediate solutions that are not very disruptive. So one thing that we typically do is we just say, hey, we can't do this segmentation initiative, not today. But how about we focus on recovery for right now? Like Sid mentioned, you have to make sure that your Veeam backups can't also get encrypted. But you can focus on recovery to begin with because it doesn't require architecture changes. It's relatively inexpensive, and basically every DCS vendor out there will support a backup and recovery solution. So for those that are familiar with the risk bow tie for functional safety, the way that it works is you have these threats that come in, you have preventative controls that prevent, hopefully, what's called the top event, the thing that happens, the bad thing that happens. And let's say that bad thing happens, from there, you have mitigating controls until you get to the end. I'm fully in favor of having a bunch of preventative controls because the last thing you want to do is get to that top event. However, let's just assume that it's going to happen. No big deal. At least we have a way that we can recover, with a defined RTO and RPO to be able to do that. Again, relatively inexpensive, not very intrusive to do something like that. So, but we work in OT. It's not IT. Like, we just can't, install a Cronus or whatever Veeam and call it a day. There's other things that we have in our environment that are critically important to what we do. Of course, servers and workstations, that should be a given. Managed switches, if we have them, great, because the last thing we want to do is those configurations to get blown out. If we have VLANs, that's a bad day. But what about PLCs? There's products out there to do that today, and some of you guys are probably already using it, things like Asset Center and stuff like that. But if you don't have a good segmentation initiative yet, my suggestion would be to let's focus on the servers, the workstations, the switches, but certainly the controllers. Like Sistrunk mentioned, typically controllers are not the things that are going to get targeted. However, it's a low-cost insurance policy that in case something happened to them, you'd be covered. but still do segmentation, please. But, okay, so let's say, and this might be a bit controversial, hopefully not. Let's say we're gonna segment. Okay, so how are we gonna do it? Let's do it by the Purdue model, because that's how we've always done it. In my experience, the Purdue model is a great way to visualize a control system. It's great on paper, like Sidstrug mentioned. It's great on paper. Realistically, I think it falls apart quickly. And we'll kind of go through a couple of those examples. But the good news is that there's already a great methodology that's an alternative to the Purdue model to do these things. And I'm sure most of you know it's IEC 6243 using zones and conduits. But let's say that you're just starting out and you don't really know how to group things into zones. You might be used to doing level 1, level 2, 3, 3.5, whatever. One thing you might want to consider is instead of putting things into a Purdue model, put them into functionality-based zones. And here are ones that I have used before, totally not comprehensive, but it's something that can be helpful, I hope, in that you group things based onto what they can do and what they can affect. So, of course, the highest one would be process safety, anything that has last line safety functionality, things that can do control. And this is where things start to deviate a little bit from Purdue in that it's things that can directly or indirectly manipulate the industrial process. So that is a PLC and that is an HMI. Even though on Purdue these are two different levels, in my mind, they can both do control. They have the same level of functionality. And then from there, you have things like process measurement, super important. Even though it may not be able to disrupt the industrial process, it's the cash register of your company. For anybody who works in oil and gas, like it's critically important. And then down to something that's, that even in the Purdue model doesn't really accommodate very well is things like process optimization. Let's say that you have some sort of cloud analytics that you're doing if you're going crazy. It can give suggestions to the process, almost like DMC, but it can't, override certain thresholds. Well, that should be in its own zone because it has a different risk profile. And then all the way down to process visibility, things like historians, stuff like that. So again, you guys can do it however you want in your organization, but this is how I have found, mostly working in oil and gas and energy, that things can mostly be grouped into this as opposed to Purdue levels. But let's say that we've done that. We have put things into zones, we've sort of grouped them based on their functionality. Now what? Because typically in the Purdue model, level 1 can only talk to level 2, which can talk to level 3 to 3.5 to 4, 4.5, 5, whatever. I think we have a lot more flexibility with zones in that we have a group of devices that can do a certain thing. What can they talk to? So should control zones be able to communicate to the internet? I don't know, maybe. That's cool with your company. That's all good by me, but at least it's documented and we know what it is. Can third-party process control zones communicate with each other and the DCS? So again, we might have these process control zones, right? They all have sort of similar functionality, but they may be managed differently. Like you might have a skid package that should be a zone, the DCS that should be a zone, something like that. Those process control zones, what can they do with each other? Can they talk to each other? Or can the DCS only initiate communication into the third-party zones? It's just things to think about. So we're going to work through it pretty quickly. And this is not the best process control network diagram, but hopefully it gets the point. Because kind of what we have here is we have a DCS on the right-hand side, and then we have some third-party stuff on the left-hand side. Up above, we have a historian, maybe an IoT gateway, and on the right, there's always lab servers or some other stuff sort of hanging off the process control network. So let's segment this thing. How would you guys do it? Well, we can start with Purdue, and it looks nice. We have our level 1 which is all of our core control. We have our level 2, our HMI, stuff like that. But then we have, oh man, shit. Man, we have to make a level 2.5 because like we need to have an interface between the DCS and the rest of the control system, but that doesn't exist in Purdue. So let's put a 2.5 there. Okay, cool, we did it. Okay, so now we have a historian. Oh, but now not only do we need a DMZ for the DCS, we also need a DMZ for the entire plant. Okay, let's just call it 3.5. Okay, that'll work. And then, oh man, but now we have these analyzers. Like, should those be on level 1? Well, they don't really do control, but they're part of the control system. So like, are they level 1? Are they level 4? Who knows? But all right, so what we're gonna do is we're gonna put them on their own level 1 for analyzers. But because in the Purdue model, well, how we have interpreted, or how I've interpreted, and a lot of other my colleagues, is that, well, when you go between these levels, you need a firewall. So okay, cool. So now we need a firewall between our PLCs and our HMIs. And some DCS vendors don't even support that. You can't even do it. Like Delta V, for instance, you know? You have your ACN and you can't have a firewall. I guess you could try. Put a firewall between your Pro Plus and your S-Series controllers. But the Purdue model says you should. And I guess what ends up happening here is that you just sort of come up with this mess of things that are shoehorned into Purdue. We have a bunch of 0.5s in there that were like never really defined well. We have PLCs down here, third-party PLC, our building management PLC, our compressor PLC, that are managed by totally different companies. And they have totally different risk profiles, but they're all level 1 because they do control. In my opinion, it's not the best way to do segmentation. Again, great to do for a visualization, but when you're doing design, I don't think it's a good idea. And if anyone disagrees with me, that's totally fine. We can talk about it. So let's try it a different way. So, okay, we're gonna go through our major functional zones and just partition things out. So for instance, process safety, the most critical, down on the right, it needs a dedicated firewall because we define that as part of our zone communication. We can say that from the process safety zone, only outbound communication is allowed, and there must be a dedicated firewall to do that communication. That's an easy enough rule for us to write, and we'll do that, and that's great. We have our process measurement zones, which includes both the lab server as well as the analyzer. One zone that's just VLANed off and then terminates on the one firewall. We have many process control zones, and anyone who's worked in large petrochemical facilities knows this to be the case, is that you have your core DCS, which in my mind would be a zone, and you have a million third-party packages that can either be grouped together or segmented out based on their risk profile. Like everyone always forgets about the sad compressor skid, that if you lose that, you lose instrument air, and then essentially the process can go down. So perhaps something of that amount of risk should be in its own zone, and then we're able to define whatever data flows can go in and out of it. Other ones from there, process optimization, our process visibility, you can kind of see that there's not really a DMZ here because we don't really care. It's based on what it can do and what it can talk to. So we could almost think like we might have a DMZ for process optimization and a DMZ for process visibility, but it's only a DMZ because it's allowed from a zoning perspective to talk in and out, to talk down into process control and then talk up into enterprise. So in my mind, it gives a lot more flexibility in what you guys can do when you stop thinking about it in what level things are, but what can it do and what can it talk to? To me, are the things that really, really matter when you're doing a design like this. Number 3, let's make it easier for our folks to get stuff done, our SIs. Something that happens a lot, and I think Chris mentioned it, is time to time, contractors need access to controllers. They need to be there, the panel's gotta be open, and they gotta be able to plug into it, and look at the I/O and look at the LEDs and do what they need to do. So how do we do that? How do we accommodate that? Well, sometimes, this sad controls engineer has RS Logics or, and he needs to, or Studio 5000, and he needs to plug into that PLC, but the policies say you can't. So, he might have to go to a jump server or do something else or just head back home. You have a remote tech who wants to use TeamViewer to be able to troubleshoot this engineering workstation. Well, the policy says you can't do that, so you're kind of out of luck. So, what happens in a real world scenario that I've seen is people go around it. They go around it every single time. So they just wait till somebody's not there, or they do whatever, and then as soon as the people who are making those rules go away, people within reason will just try to get their job done. So they'll plug directly into the control network. It's how a lot of malware enters control systems. Or somebody will install TeamViewer, and then they'll get a direct access back to the engineering workstation. So if we put in these hard no's, which some of them, in some cases, might actually make sense for your organization, but I would contend that maybe we say yes conditionally, and we make it easy to do. So what are a couple of options that we have? For scenario one there, we have a tech that needs to plug directly into the control network. So this is one thing that I've implemented before, and it may work for you guys, is that make port 1 on all of your managed switches in your cabinets a dedicated port that goes to a dedicated VLAN. Call it whatever VLAN you want, 900, 666, who cares? And that one port goes back to the firewall. It gives the SI engineer a DHCP lease, so they don't have to give themselves a static IP, because another issue you'll see in this is that you get duplicate IPs, and it can shut down the process. This prevents something like that. So they plug into port 1, always port 1, they get a DHCP lease, and they're able to, via the firewall, get to the controller. So we've implemented some security here. If he has malware on his laptop, it's probably not targeting PLCs. It's probably commodity malware that's targeting other Windows workstations. In this scenario, they can't talk to other Windows workstations. They can still get their job done, but we have some levels of protection. And then for remote access, no super mystery here, but there are tons of tools out there. Some of the guys out there sell them, in that you can do very easy vendor onboarding to be able to do just-in-time troubleshooting. They don't need to be completely onboarded into your SAP and HR. You get screen recording, all sorts of good stuff. So we're not saying no, we're saying conditionally yes, and then this is how you can do your job. And there's tons of examples like this where just using little small tweaks in some of your designs, you can make some big quality of life changes for your SIs. And the fourth one here is around just being proactive. I have been on the other side of managing these facilities where there are slow polling rates, things are dropping off the domain, and we don't know why. And for you guys who have worked in facilities for a while, if there is something that's deemed to be perhaps a network issue, and the maintenance tech goes out, what do they do? Anyone? They throw it in the trash, they put another one in. That's what I've seen. And so doing that sort of thing almost never actually solves the issue. You might have a bad fiber, you might have a misconfiguration in the switch. It is almost never a hardware issue in the switch. So with some of this managed infrastructure, it can give us some of that needed visibility to diagnose these issues. So what issues have we seen? Me personally, I've seen an actual dead rat up in Utah covering the ventilation, causing the tag server to shut down on high temperatures. And it did that for months, and because no one wanted to go in the back of that panel. Another one, and this was offshore. So there was a switching loop on a couple of unmanaged switches that would lead to network saturation, and the HMI would drop poles for I think, yeah, it was about 3 years. And no one knew because it was a switching loop on unmanaged switches that were above the plenum in the ceiling. And because the switches, I think they were Entrons, they didn't have the processing power to take down the complete network. It was just sporadic because the processor couldn't handle it, so it would handle it a little bit and then it would drop some packets and then handle it a little bit. Anyway, those sort of things. And something that you guys might see, particularly if you're a Rockwell shop, is produce consume traffic. If you use that sort of messaging, it uses multicast, and you might have multicast flooding going to your Rockwell switches or Allen Bradley PLCs. So you can have these network floods because if you don't set up multicast correctly or you use unmanaged switches for this produce consume multicast, essentially what happens is that packet, instead of being directed to what it needs to be directed to, floods the entire network. So if you don't have that visibility, these sort of things can happen. And of course, there's many more. So here, what do we kind of do about it? There's a lot of simple things, again, and this does not require a large segmentation exercise. This is just simple telemetry that your IT folks have used for a long time, and honestly, it works quite well in OT. It's not very invasive. These are proven technologies that, in my experience, can be rather easily translated from the IT into the OT environment. So that's things like you can just ping the controllers. Unless you have a terribly ancient controller, they can typically handle ping. Some of them even handle SNMP, like Rockwell EN2TRs can handle that just fine. SNMP and SSH to your managed switches, if you have them, any basic NMS can take care of that. And then for your Windows workstations, you can use things like WinRM or WMI or even just basic ping just to check uptime. And I'm telling you, you guys it'll save you a world of pain. So just a couple of quick takeaways here. One, the very first thing that we talked about, please, please, please treat OT cybersecurity projects as an engineering discipline and follow their cadence, even if it's different than your IT PMO cadence, because that facility is going to get built with or without IT PMO involved. Let's focus on functionality instead of the Purdue model. Again, we get a lot of the same results, but from an engineer standpoint, a network design engineer standpoint, I have found that using that functionality-based zones to be much more helpful. We want to design the OT infrastructure based on the reality of these environments, not how it looks on paper. There are a lot of vendors, there's a lot of equipment, and they have massively different risk profile. It's not just that the thing can do control, it's what can it control. And then next, start small. We don't have to do something super expensive as asset owners to be able to start to secure our environment. There's simple things like that backup and recovery that we can do that's not expensive. It won't have effects on regulation, and we get to a point where if something happens, we can recover. And the fourth, and again, the most important one, if you take nothing else away, is keep that end user experience in mind, because if you don't, they'll go around you. So thank you guys. If you have any questions, I'm here to answer them. Appreciate it. Sure. Uh-huh.
In the image, it's easy to identify the different zones that you created based on functionality.
Mm-hmm.
How do you physically, logically segment them? It's okay.
So you mean like from a technical, like a physical segmentation versus like VLAN segmentation?
Right, so here on the design, we can easily see how you segment or create zones based on functionality, right? The devices. How do you implement segmenting those different zones? What conduits do you use? Do you need firewalls between every one of those zones that you created?
Yeah, so typically the way that I do it is to keep things simple, to keep things simple, there will be a DCS network environment. That's sort of that engineered package system. It's just done that way. Then there's third-party packages. That is one switching infrastructure that can have multiple VLANs in them. It could be like upwards of 30, right? Depending on how many zones you have, because typically there's a one-to-one mapping between zones and VLANs. And that will all shuttle up to a pair of firewalls, the IT/OT interface firewalls. You don't have to do it that way, but I have at least found that it makes it easier from a maintenance standpoint. Instead of having 30 sets of switches, you have one. And instead of having firewalls all over the place, you have one policy that is really cranked down instead of having a bunch of different firewalls. That's how I do it. I'm sure there's other ways as well.